Good evening, my YouTube viewers. In this video, what we're going to do is we're going to perform a hypothesis test concerning some drug trials. And the practice question that we're going to be covering is, a drug has a minimum of 5 milligrams per dose. Ensure the concentration does not fall below this level. Perform a one-tailed left test to check for a significant decrease in the sample mean. So the null hypothesis is the sample mean is greater than or equal to 5 milligrams. And the alternate hypothesis is the sample mean is less than 5 milligrams. So what we're going to do is we're going to write a program in Python to solve this problem. But before we write the program in Python, we're going to have to import some libraries, because in order to import the libraries, we need to do that in order to execute the program. So the first library that we're going to import is NumPy SNP. NumPy is a numeric library. It performs numerical computations. It creates NumPy arrays, and it also creates distributions. We're going to import scipy.stats as stats. Scipy is Python's scientific library, and stats is a statistical module within scipy. And we're going to import matplotlib.pyplot as plt, which is a visualization library. So after we have imported our libraries, what we're going to do is we're going to set our parameters. So the population mean equals 5. The sample size is 20. The sample mean is 4.9. The standard deviation is 0.4. And the alpha is 0.5. I just want to check something real quick. Okay, so what we're going to do is we're going to calculate the t-score, but let me just check the t-score very quickly here. Okay, so what I did was I calculated the values on my calculator, and I just wanted to make sure that the values on my calculator were the same as what Python calculated. And obviously Python can calculate things a lot better than I can, but I just wanted to check it. So the t-score equals the sample mean minus the population mean divided by the standard deviation divided the square root of the sample size. And so the t-score is neg 1.1180. And now we're going to calculate the p-value. So the p-value for a one-tailed t-test equals stats.t.cdf. So t is your t-distribution, and cdf is your cumulative distribution function. Brackets t-score, comma, degree of freedom equals the sample size minus 1, and the sample size is 20, so that's going to be 19. And then so you're going to print the t-score and the p-value. And so what we're going to do is we're going to analyze the p-value. If the p-value is less than alpha, which is 0.05, you're going to reject the null hypothesis, as the sample mean is significantly lower than the population mean. If the p-value is greater than alpha, which is 0.05, you're going to fail to reject the null hypothesis because the sample mean is not significantly lower than the population mean. So now what we're going to do is we're going to plot the t-distribution. So x equals np.linespace, brackets neg 4, 4, 1000, and y equals stats.t.pdf. So t is your t-distribution, and pdf is your probability distribution function. Brackets x, df, sample size minus 1 is 19, I believe. And then we're going to plot the t-distribution, plt.plot, brackets x, y, label equals t-distribution, color equals blue. So we're going to shade the critical region for a one-tailed right test. Critical value equals stats.t.ppf. T is for the t-distribution, and the ppf is for the percentage point function, brackets 1 minus alpha, comma, df equals sample size minus 1, so that'll be 19. And then plt dot fill between brackets x, comma, 0, comma, y, comma, where brackets x is greater than or equal to critical value, comma, color equals red, comma, alpha equals 0.5, comma, label equals critical region. So we're going to mark the t-score on the plot, plt.ax line, brackets t-score, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals t-score. So we're going to add labels and titles. So the title is One-Tailed Right t-test. The X label is t-score. The Y label is probability density. And you get a legend. And then we're going to plot it. And so when we plot it, you can see that your t-score is negative 1.1180, which we already calculated on the calculator. And the p-value is 0.1387. So the p-value is greater than the alpha of 0.05. So that means you failed to reject the null hypothesis. The sample mean is not significantly lower than the population mean. So let's just come back here and see what the sample mean is. Sample mean is 4.9 and the population mean is 5. So it's 0.1% difference between the sample mean and the population mean. And so this is the diagram that we have made. As you can see, the blue is your t-distribution and your red is your critical region, and your t-score is neg 1.12, and the t-score falls within the the normal region of the t-test. So that concludes this video. The next video is going to be another hypothesis test, and so I hope that you decide to watch it.